To start filling in our curly implementation, we need to parse our new syntactic forms. Let's look first at parsing a record form. So a record always starts with the keyword record, and then it has in curly braces some symbol, like X or Y, combined with an arbitrary expression. So we're going to need to parse each of these expressions. Dot 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 here means that we have any number of these two-element lists. So for record E, we need to use map to look at those lists. So we'll take S, which is the overall thing, turn it into a list, and use rest, so we drop the keyword record. So we have a list of these S expressions. And then record wants the names and the expressions in separate lists, so that's why we have two map calls. The first map call is meant to get each name out of this inner list. So we convert the list, the S expression, to a list, take the first out, and coerce that thing to a symbol, a plain old symbol instead of an S expression. So we know it's going to be a symbol, so we know this SX arrow symbol will succeed since it matched the pattern. For the any side, though, it's similar. We take the second in the list, and then we call parse to recursively parse that expression. Make sure it's a valid expression, and that way we get an expression here. So map gives us a list of expressions. We get a symbol here, so this map gives us a list of symbols, and we've parsed it out just the way we want. I'll skip over get and set because those are straightforward to parse, and you can look at the code on the web page. Let's jump on to interp and look first at interpreting a record expression. So what we have is a list of names and a list of expressions for the initial values for the record. Since those are expressions, we'll need to interp them. Since it's a list of expressions, we can't just call interp directly on VS, but we can call interp on each individual V in VS. So we'll use map again to do that. Map over the list of expressions, interpreting each one. What we get back is a list of values, and we have a list of symbols here, and those are exactly the two parts that we want in a record V. Got a list of names and a list of values. That's all there is to evaluating a record E expression. Let's look at the get E part. We have an expression for the record and a symbol for the name. Since this is an expression for the record, we will need to interpret. And then somehow, we expect to get a record back. So let's do a type case to make sure that this interp of R gives us a rec V. If it's not a rec V, then we complain, as usual, that we got the wrong kind of value with not a record. Now we have a rec V, which has a list of names and a parallel list of values. And we have n from the get expression, which is the name we want to find. So this n needs to be in this ns somewhere. If it's not, then we can complain that the field doesn't exist. But if n is in that list, then we need, at the same position, the corresponding value. So let's push that out into a helper function, find, which is straightforward to write. It takes a list of symbols and a list of values. It looks for this symbol in the list of symbols and returns the corresponding value. Right? As soon as we do that, that's all the work of get. And we'll leave it up to find to complain if it cannot find the symbol as well. Set is the last piece that we have to implement. So set has two expressions, a record expression and a value expression. We will need to interp both of those. And we also have a symbol. This symbol is similar to the one in get. We need to find it in the record. First, let's make sure that this is a record. So we type case to make sure that the R expression gave us a rec V back. If it did, now again we have a name and a list of names, and we have a list of values. In this case, we don't want the value that corresponds to the name. That's exactly the one that we want to replace. But similar to how we did it for get, let's push the interesting work into an update function. So the update function is going to take a name and a new value, and a list of names and a list of values. And its job is to give us back a list of values that is updated to replace the one for n with the value here. And again, if the field doesn't exist already there, then we'll leave it to update to complain about it. This gives us just a list of values. That's not what we want as the result. Set is supposed to return a new record, so we need to wrap this with a rec V. So we got a new list of values. We can keep the old list of names. Our update is not going to be allowed to add new fields, just update the values of fields. And when I say update, I mean give us a new record back, not changing the old record, of course. It's worth looking at the update function just a little bit. Here it is. It takes a symbol and a value, So a symbol that must already be in the list of symbols and a value to go in place of that one in VS. I'm writing this one with cond instead of typecase just because I have two lists to deal with and it turns out to be a little more compact. Same idea though, we still have the empty in the cons case. If we have an empty list of names, which will mean an empty list of values also, that means we didn't find the field and we can complain about it. Otherwise, we check whether the first field name matches. If it does, then the first value is the one we want to replace. So we keep the rest of them and cons on the new value. Otherwise, this is not the symbol we were looking for. We want to keep the first value and add that back on to the recursive call, where we look in the rest of the names for the name using the rest of the values, looking to replace one of them with v.